Okay, now the next talk is John Dingley to tell us about a decade of making self-stabilizing ride-on robots.
Hello everybody, my name's John Dingley. I've never been to the EMF camp before, but I'll definitely come next year. There are a few friends I recognise from various maker fairs over the years. I have to give you a spoiler alert. I'm not an engineer, hardware or software, but my hobbies drift very much into that area. And as I've learned things over the years, it has actually helped me with my job. I'm actually what the Americans would call an anesthesiologist. So in medical terms, that means I'm a gas man. So I found this video back in 2008 when I was starting this hobby, and this was a guy in America who's now a Microsoft software engineer. He was trying to build a self-balancing skateboard, and he summed up the pains of this experience quite succinctly here. So I'll just play this short clip.
Riding this device is like being on an episode of Jackass. You're bound to get hurt, it's bound to be funny, but it's bound to be painful.
Yeah, and I can attest to all those things. So why did I start this hobby? It's something crazy. Well, if you look at things like popular mechanics right back to the 1940s, there are all these wonderful devices with one wheel, tanks, motorbikes, with heroic people doing heroic things on them. And in fact, in 2001, in a German university, they'd obviously got hold of some sort of early gyro, solid-state digital gyro unit, and they built this unicycle which had a go-kart tire, which was extremely wide, which balanced itself rather in the same way as a Segway, which actually came later. I then found a video from Norfolk, of all places. This is a guy who built a skateboard called Ben Smither. He was a Lotus software engineer, as it turns out, and they are the main tech employer in Norfolk, after all. And he put this brilliant video up on YouTube.
Go for it.
Inspired me. So, as you can see, it balances beautifully. Now, this was before Segways were really well known, and it was certainly before all these devices from China. So back in the day, this was quite a phenomenal thing to see. And it really inspired me to build something like this. I was wanting to advance my electronics from my sort of schoolboy experiences and get into microcontroller programming. So I thought, I'll build one of these. How hard can it be? Well, actually, it is quite hard. So what do I need? I need a motor. That's okay. That's okay. I understand that. Some sort of power controller. That needs to be controlled by a computer. How does a computer control the power controller? Don't know. Have to read up on that. But we've got the internet. It was going okay in 2007. So you need these sensors called accelerometers and gyros. What do they do? How do you use them? Not sure, but I know I need them. So, right. Okay. Have to look into that, read up on that. How do you use the data? What maths do you do on the data from these sensors to tell the motor how fast to go to stop you falling over? Don't know, but we have to look at that as well. So a lot of reading required here. What software? What code? What coding language do I need? I write that on my laptop, I know that, and I transfer it to some sort of little computer in the board, in the, like, microcontroller. I know that. How do I get it from my laptop to the microcontroller? Don't know. Right, have to read that up. So that's where we were. Anyway, I knew how to code because I'd done that when I was 14, because I built myself one of these fabulous Sinclair computers. Now, many of you are too young to remember this, but this was phenomenal. You could actually build a programmable computer attached to your TV that did things for hardly any money. Bearing in mind the school computer at the time was from the university, second-hand, and it filled the whole room. So this was amazing stuff. So, well, here's the microcontroller I got. Arduino boards hadn't come out yet. It looks a bit like a kind of proto-Arduino. It was from Active Robots. It came with almost no documentation. So I knew you programmed it in C. I know it had inputs from sensors and outputs that you could use to control things, and a big sort of socket here, which you somehow plugged your laptop to load the software onto it. So I thought, right, we've got the brain, so now I need to know how to program in C. Right, Well, I know some basic, so I thought, well, C must be sort of similar to basic, surely. So I downloaded the whole book of C and printed it out as a PDF, which turned out to be about that thick, like a dictionary of C. So I started studying that. And I thought, well, I've got to write this program. What do I write it on? What environment do I use? So, you know, the internet's come on a bit since then. It wasn't that obvious how you did these things, but I knew that the manufacturer of the chip had a programming environment called AVR Studio, which is this thing here, that you could write your program in and save it onto your hard drive. Great. How do you get the program from your laptop onto the microcontroller? Again, to you guys, that's like dead simple. But if you searched that at the time on the web, it wasn't clear. It was sort of assumed you knew. So, right. So, had about a week of surfing the web, I found this odd program called PonyProg, which would allow you to plug a parallel port lead in one end and the other end of the cable into the board, and you could get your program onto the microcontroller, so we can program the brain of our machine. Great, so we're making progress. That's about a month of work there to get to that point. Now, I was helped, my life was saved by this guy, Shane Colton. He's a lecturer at MIT. Aren't these guys always at MIT, it would seem? He ran a course on getting his mechatronics students to build segways. So how do you use the data from an accelerometer and a gyro in some sort of useful way to control something like a Segway? And he actually explained it in reasonably simple terms and reasonably simple maths that I could understand. So, why do you need a gyro? Why do you need an accelerometer? A gyroscope used to be a thing. I'll just show you how technology is advanced. This is a Vulcan bomber gyroscope unit for the autopilot. Okay, so I've got a friend who's into retro aircraft,